It's true. I took over an hour and I awkwardly followed each one of these machines, and the guys let me do it. It was a lot of fun. You see how that machine is pulling out those ties? That's an immense amount of force. It takes 27,000 pounds that it can exert to pull that out. And it only does that because the spikes have already been removed. So there's nothing really holding it down. But there's a part on there, these grips, that lift the rails up. They kind of like bow it up. They don't bend it or deform it, but it bows up. That's an immense amount of force. Here's a close-up of the arms. Now this thing is called the tie remover inserter, TRIP for short, and it's from a brand called Nordco. So it also pulls out the ties, but can put back in the new ties later. If you look there, it's angled down. From where the guy sits in there, the glass is angled down so they can see exactly what they're doing as they drive forward on the rail. Some of the wood is so rotted, it's kind of obliterated when they pull it out. This is why they're replacing some of these lines. The wood really can't be recycled, but it's taken to a facility in Texarkana that grinds it up for some purpose, but I don't know yet. We need to know the parts of a rail. Of course, you have the rail, which is the metal part. Here we have a weld seam. And then this is the main components here. This is called a sleeper sometimes, but many times it's just called a railroad tie. Here we have an anchor. Sometimes they get out of place, but it's used to hold this all in place as things shift over time, decades of use, temperature changes, and so forth. Here we have the spikes. They're about this big. You can walk around railroads and find them everywhere. This is the base plate, and we have spikes on both sides. Another thing that we have are these tie connectors with these large bolts that are connected together. So what we have here is one form of connecting them together or repair, and another form, the weld seam right here. This is a 24-mile-long project in Harlingen with a company called Union Pacific. They cover about 7 states, so these guys go all over. And they can go about 2 to 2.5 miles a day with this repair. This is the anchor. It sits underneath the rail and kind of hugs side by side on the ties. And this is called here I wrote it down. It's by a company named Racine, and this is the dual anchor spreader, or DASS. And it goes in there and it moves the anchors to the side so that new ties can be inserted in later. Here you can see the distance the anchors have been spread from side to side so that the ties can be inserted in later. So this is the same machine that you saw earlier. The one that removes the ties is the same machine that inserts the ties. This company, this one was made by a company called Nordco, and it's called TRIP, Tie Remover Inserter. And it has over an 80-inch stroke length. It seems to take less force to insert the ties, so it's sitting around 13,000 pounds of force that it has to insert instead of the 27,000 pounds that it needs to remove. I think this is the coolest looking of all the vehicles in this entire train line. This machine is from Varsco. It's called a ballast timber machine. Yeah, the ballast is the rock that's there, and it is put there on purpose for multiple reasons. But right now it's forcing the ballast or all that rock underneath the tie. If you notice, there is gripping arms that grab the tie, pull it up, and then force all that rock underneath it. So it's got several arms moving it. All these metal plates here are used to help connect the rail to the ties, and they have to be put back in place. So these group of guys have a machine that pulls the railing up, and they put the plates underneath the rail, and then it puts the railing back down. So it does all that heavy lifting, and then they just connect it and guide it. This machine is adding in all the spikes. If you notice, they have it marked green, so the guys doing all the work know where to go. This is the Nordco Production Spike Driver, sometimes called the CX Hammer, and it provides about 2,200 pounds of force to pound those spikes in place. If you notice, the front of the cab is angled, so the driver can actually look right down at where they're striking. I noticed that there was a different one on the production line, and this was a small spiker, sometimes called the SS Spiker. And this last one right here, this is called the ballast regulator, and it goes around and it regulates or moves into place all of that ballast, gets it situated correctly, and it has this really thick, I guess, plastic or rubber brush that it uses to put it in place, and then it has some wings that go down and help shape the sides. The ballast is real important. It's real important for drainage, and it's real important to keep vegetation down. As trains drive by, it's a risk that things can catch fire, especially from those older trains that were powered by coal. So I spent about 3 days trying to find these machines and learn about them. I only tracked out, I think, 9 of them. There was probably 10 machines altogether. The only one that I didn't find was the one that removes the spikes, but I think I found all the other ones. One thing that I want to pass on to you is I talked to one of the foremen that's running the lines, and he told me that in the past they used to have this machine that was like $25 million, and it would do everything all the other machines were doing. It would remove the spikes, it would pull out the ties, move the anchors, put in the ties, straighten everything, put in the plates, move the ballast, and spike everything down and finalize everything. But he said the problem was whenever one part wasn't working, the whole system wouldn't work. So if the part that comes and moves the ballast, all the rock underneath it, if those mechanical arms were broken, then you couldn't work because that one part had to be repaired. And this is kind of common in heavy machinery, that things tend to break down and they need repaired. So he said it turns out it was a lot cheaper to just have machines that specialize in doing some of the tasks, and having a whole gang train of those. That way, if one machine doesn't work, you can still get the other ones working, and maybe you can rent one of the other machines to finish up the job. So in the wide world of engineering, I want you to consider that there are multiple solutions to solve a problem. And if you notice, I mentioned about 3 different brands. I didn't even know that there were companies that made machines to repair railroads. Just something I didn't think about. So With all that's available to you as an engineer to design, to fix things, to make things better, there's a lot out there that you haven't run into that is available that you could solve.